Hello everyone, welcome to the BOOKphilic YouTube channel. Now in this video we are going to understand the parser or syntax analyzer. So I have discussed already in our previous videos that there is different phases of compiler, just like lexical analyzer, syntax analyzer. So we have discussed in the lexical analyzer tokens, lexemes and patterns. But now we are going to understand the syntax analyzer, which is also known as the parser. So we have understood what is taken as an input in the syntax analyzer and what is taken as an output from the syntax analyzer. Yes, if you have learned, if you have remembered, then you will be understanding that the tokens will be taken as an input to the syntax analyzer, and the parse tree will be generated from the syntax analyzer, which will be the output of the syntax analyzer. Since the parse tree is generated from the syntax analyzer, that's why this syntax analyzer has gotten the a noun which is known as a parser. So whenever you will be asked in your college by your ma'am or your sir, you will just answer that a parser is nothing but a syntax analyzer phase of a compiler design. So now in this case we are going to discuss the syntax analyzer. So let us move on. So here we go. At first, we are going to discuss parser and syntax analyzer. So here it is definition of how the start symbol of a grammar derives the string in the language. It is a definition of how the start symbol of a grammar derives a string in the language. So whenever you will be given a production rule, you will be given a string as well in order to derive the string from the given production rule. So here we need to understand these 3 points. We need to remember these 3 points. These are the logical things. Whenever you have watched a tree, whether it is a tree of mango, whether it is a tree of strawberries, whatever it is, you might have noticed that a tree starts growing from its root and ends in its leaf. So whenever a tree will be called, then you might have to understand that the tree will start growing from its root and will end into its leaf. So let us start from the first point, that is, or I written over here, that is the first point is that root is always the start symbol. So I have already told you that let us make a tree so that you can feel the concept of the parser. Okay, so this is our tree. Okay, this tree has started growing from its root. This tree has started growing from its root, and after that stem has come, and at last there is a leaf. So this leaf is nothing but the end of the tree, after which the tree cannot grow. Have you ever seen a tree to grow after the leaf? No, leaf is the ending node of the tree. So what is written here? This is written here that root is always the start symbol of a tree, and it is the root. It is the root. All the leaf nodes are terminals. So what is the leaf? These leaf, this leaf, this leaf, whatever these leaves, this is nothing but the end of the tree. That's why this is known as terminal. And all interior or intermediate nodes are non-terminal. That is, whatever in between this root and the leaf, it is known as intermediate, and it is not known as non-terminal, which is nothing but the stems, which can be derived further on. You might have seen that a stem can generate another stem, or you can say that a branch can generate another branch in a tree. That's why this is known as interior or intermediate nodes or non-terminals, which can be further on derived into leaves, and these leaves cannot be derived further on. So these 3 points you have to remember. This is the logical points you can write in your notes. Okay, let us start with a few examples where it is written that example number 1. So we are giving the production rule: S derives capital X, capital Y, capital Z. in the next production rule we are given that these x y z are nothing but the stems of the tree. So you have to understand that this x will be derived into its leaf node, that is x derived into a and y has been derived into b and z has been derived into small c or d, you can say that. So we have to first of all generate the parse tree, because we are understanding the concept of a parser. So parser will be doing the function of generating the parse tree. So here it is, the capital S is nothing but the root of the node, root of the parse tree. So it will be starting symbol and it will be started from S to X, Y and Z. This is nothing but the stem of the tree, and at last it has been derived into small a, small b or c or d. So here it is a shortcut we have used. You can regenerate the parse tree by generating here the d. First of all you have to take this c and then you will have to take this d. So for our shortcut we have just written c or d. Okay, the parse tree will be same as it is. So now we have to understand which language the grammar has produced. So we have to see that we have gotten this capital, this is small a, this is small b or this is small c. So first of all this abc has been generated from this grammar. So this is a language, and at last we are getting this is small a again, this is small b again, and at we in place of c we have written d. So we have gotten this abd. So you can say that the language which can be generated from this given production rule is nothing but abc comma abd. We use this comma to separate the language, and we use this in these curly braces in order to represent the language of the grammar. So we can say that the language of the grammar is nothing but abc and abd. This is how you have to you have to understand the concept of a parser. So let us move on to the next example. Okay, so let us move on. So in the next example we are getting this capital T derives capital T plus capital T. Here it is. And in the next we are getting this capital T is deriving the capital T star capital T. And here it is also capital T is deriving small a, small b, small c, which is nothing but the terminal or the leaf node of the parse tree. So we are getting the output string as a star b plus c. So our main target is to generate this a plus a star b plus c. So in order to generate this a star b plus c, we will be starting from a plus t plus t, or we can start from t star t as well. In either case you will get the same syntax. Okay, so we are getting started with the t plus t. So we are getting this plus at last, so hence we have to derive this is capital T into star as well, so that we can get this star, and ultimately we will be deriving this left to right, because we are getting the syntax using the LMD property that we have discussed in our previous lectures. So a star, then we are deriving in the next step b, and at last we are deriving it into c. So ultimately we have gotten our syntax. Yes, we have gotten our syntax a star b plus c. So now ultimately we have to generate the parse tree, because we are a parser. You have to consider yourself as a parser, then only you can generate a parse tree. So here we go, we are first of all generating our root node, that is capital E, and then in the next step we are generating e plus e, and then ultimately we are generating into respective id, and in this case e we are getting our star symbol. That's why first of all it is generated into, it has been derived into capital E star capital E, and then ultimately id. So hope you have understood how we are getting this syntax a star b plus c. So this is the parse tree generation, and this is the main function of a parser. Okay, in our next upcoming videos we are going to understand the types of parser. For the time being now, you can learn and go to earn. Thank you very much.